Hi dear students and viewers, welcome back to our channel N. Vinay Kumar Basics of Physics. Dear students, in this video we are going to discuss about the one of the most important topic in the 10th class and in the chapter of electric current, that is what is Ohm's law and how it can verified with one experiment. That is the most important for children, 4 marks, and from that so many questions will be asked in public examinations in different manner. The one question should be like this: explain the activity to prove the Ohm's law. That is a direct question. And second question is how we can prove the Ohm's law. Explain it one experiment, say like that. And third pattern is the material required in the experiment to prove the Ohm's law. So that type of questions will be asked. In the CC pattern, the question should be maybe direct or indirect. If you have idea about the answer, you can easily write the answer. So children, that's why you have to watch the video up to last without any skip. Clear? So the first thing is here in this video, you have to know about the first thing, what is Ohm's law and what is meant by ohmic and non-ohmic conductors, and next thing is what are the limitations of Ohm's law. Let's discuss that. Here the first thing is what is Ohm's law. What is Ohm's law? Here the Ohm's law is, here what it is, the potential difference between two ends of a conductor, is directly proportional to amount of current in the same conductor, at constant temperature. So this is what we call Ohm's law, children. The potential difference between two ends of a conductor is directly proportional to the amount of current passing through the same conductor at constant temperature. This is what we call Ohm's law. For example, here now this is the conductor and I am saying this is the P and it is the Q. The potential difference what we apply, that is what V here, and the amount of current is what? I. So then what do you write? V is proportional to I. What is V? Potential difference. And what is I? Current. Current. So V is proportional to I. This is called as Ohm's law. Got it, children? So from that, they are in proportion. To equate them, we are using one constant, that is the R. What is R? So R is called here constant, proportionality constant, or resistance. What it is? Resistance. So what is meant by resistance? The opposition shown by the conductor to the flow of electrons in a conductor, that should be called resistance. What do we call? Resistance. The opposition shown by the conductor to the flow of electrons in the conductor, that should be what we call resistance. So children, the unit of resistance is ohm. What it is? Ohm. Clear? Now here V is equals to IR. From that I am going to write R is equals to V by I. So children, what is V? Potential difference applied between the two ends of a conductor. And what is I? Amount of current in the same conductor. Then the ratio of these two is called resistance. The ratio of potential difference between the two ends of a conductor to the amount of current in the same conductor, that should be called resistance. R is equals to V by I. So children, in examination point of view, there is one more question is there. Define 1 ohm. Or 2 marks it will be given. Define ohm. So how we can define the ohm? 1 ohm. Let's see here. Simply R is equals to what? R is equals to V by I. So here now we can write 1 ohm is equals to 1 volt per 1 ampere. Clear? What is 1 ohm is equals to 1 volt per 1 ampere. Here children, volt is the unit for potential difference and ampere is the unit for current. Unit for current. So volt is what? Unit of potential difference and ampere is what? Unit of current. So now here how we can define the 1 ohm? Like this. It is the conductor. It is the conductor and there it ends up P and Q. In between P and Q, here 1 volt potential is applied. 1 volt potential is applied between these two. Then if 1 ampere current, then 1 ampere current is passing through the conductor, then the amount of resistance of the conductor is said to be 1 ohm. Got it children? When 1 volt potential difference is applied between the ends of a conductor, then how much current is passing through the conductor? 1 ampere. 1 ampere. Then the resistance of the conductor is said to be 1 ohm. Clear? When 1 ampere current is passing through the conductor, when 1 volt potential difference is applied between the ends of the conductor, then the resistance of the conductor is said to be, what is it children? Dear students, how we can verify the Ohm's law? So children, throughout the experiment we have to use the one conductor. For a conductor, resistance is constant. Clear? So just only we discussed what it is. Ohm's law. V is proportional to I. V is proportional to I. And what we wrote? V is equals to IR. V is equals to IR. This is what we call Ohm's law. V is equals to IR. From that, if we can prove V by I is equals to constant. Look here. So what is Ohm's law? V is equals to IR. And from that, if we can show that V by I is equals to constant. Here V by I is nothing but what? Here V by I is what? Resistance value. Resistance value. That means the conductor what we have taken, for that the resistance value is constant. If you can prove that, automatically Ohm's law is verified. Clear children? So if we can show that V by I is constant, then Ohm's law is verified. Dear students, the materials required to do this experiment: one is battery, number 2 ammeter, number 3 plug key, and number 4 connecting wires, and one more conductor, that is what? Iron spoke or iron rod. Clear? So look here, the experimental setup should be like this. So these two are the connecting wires and this is the battery. This is higher potential and this is lower potential, and this is the what? Ammeter, and this is the plug key. Clear? And after that we are having one iron spoke, and that should be connected in between these two. So now it is what children? Iron spoke. Here iron spoke can be acts as the conductor. Now what is meant by conductor? Which carries the current? Those are called conductors. So children, here now first you have to look at this one. Instead of this battery symbol, now we have to take the dry cells. So we have to take the number of dry cells. Each one carries the 1.5 volts. Each one carries the 1.5 volts. So here this battery symbol indicates the nothing but dry cells. What it is? Dry cells. What is the purpose of battery? Battery can create the potential difference, supplies the potential difference. And what is the use of ammeter? By using the ammeter, what we can measure? Current. By using the ammeter, we can measure the current. And now it is the plug key. So children, when key is closed, then the circuit is simply here nowadays closed circuit, and there should be allows the current. When key is closed, now this circuit becomes as a closed circuit. Then the current is passing through the conductor. When key is open, then the circuit should be taken as open circuit. In open circuit, there is no moving of current. So these are the parts we are using the Ohm's law experiment. Just I already told you starting of the video what it is. Sometimes they will ask only circuit diagram and material required for 4 marks question. That's why you have to understand the each and every part of the circuit. Clear? And now here the first procedure. What is the procedure and what you have to do? Clear? So for that, children, first you have to take the one dry cell. We are taking so many dry cells. First thing here, first dry cell it is given. How much voltage? What we are saying? 1.5. So when we are using the 1.5 dry cell, the potential difference is created also 1.5 volts. That's why already here in our notes or anything whatever may be here, there you have to mention the first voltage. How much here? 1.5 volts. So when the circuit should be connected like this, now you have to close the key. First thing is what we are taken. We are taken one battery, thus we have the potential 1.5. After that we are closing the key and the connection should be given like this. P and Q are connected by the iron spoke, or iron spoke must be given between the P and Q. Then obviously when the key is closed, what we are to take? S. The current should be moving in the circuit and that should be shown by the ammeter. The value of current should be shown in the ammeter. Clear? Then the value what is showing there, that should be noted like this here. Whatever may be some 0.2 or 0.5. I am writing some, just it is not exactly true. Just to understand I am drawing that. So 1.5 we are taken. Then how much you got? 0.5. Then obviously here what do you get? 1.5 by 0.5 means what? 15 by 5. That is what? 3 ohms. What is 3 ohms? And second step. Now we have to take the two dry cells. So they should be shouldered with wire. So here now this is the first dry cell of 1.5 and this is the second one is 1.5. 1.5, 3 volts. So this combination of dry cell should be used as the battery. Now the second case. Clear? Instead of this battery, what you have to give? Series combination of these two dry cells. Now again the same, we have to repeat the same procedure. What it is? We have to repeat the same procedure. Then what do you get here? 1.5 means what? 3 volts. Then for 3 volts again you have to check how much current is shown in the ammeter. For example, I am going to take now it is 1 ampere. What it is? 1 ampere. Then you have to substitute again 3 by 1. That is what you get here, 3 ohms. Clear? And next time we have to take the one more dry cell. Now 1.5. What it is? 4.5 volts. This combination is used as a battery, and again we are closing the switch. Again the current is passing through this one. Again that will show some value here. 4.5 volts is what we applied potential difference, and we are feeling that it is showing some current is 1.5 amperes. Then what write? V by I, 4.5 by 1.5. Then what you get? Again 3 ohms. So that's why by increasing the dry cells we have to increase the potential. Corresponding to that we have to find out we have to note the value shown by the ammeter, and that should be noted in a table form like that. So next one is what? Some 6. Again 7.5. So by increasing the voltage, we have to find out the corresponding current values. By taking off these two ratio, by taking off ratio of these two, at every time we have to get the same value of resistance, constant value. So when we are getting like this, then what I have to say? Ohm's law is verified. So at every time what we got? V by I is what we got? 3 ohms. So this 3 ohm is the resistance of this particular conductor, that is the same throughout the experiment. That's why what you have to say? Ohm's law is verified. What you have to say? Ohm's law is verified. So children, in this way Ohm's law can be verified in our laboratory. Clear? And now you have to know what is mean by ohmic device and non-ohmic device. Are ohmic conductors or non-ohmic conductors? Children, important for 2 marks questions and 1 mark objective bits also, but it is important. Clear? What is ohmic conductor or ohmic device and what is mean by non-ohmic or non-ohmic conductor? Simply, the conductors which can obey the Ohm's law, they are called as the ohmic conductors. Ohmic conductors or non-ohmic conductors. Ohmic conductors or ohmic devices. Ohmic devices. Clear? So the conductors which can obey, they are called ohmic conductors. For example, if the conductors are not obey the Ohm's law, then it is called as non-ohmic conductor or non-ohmic device. Non-ohmic device. Clear, children? So here Ohm's law should be decides the or classifies the material into 2 types: ohmic conductors and non-ohmic conductors. Which can obey the Ohm's law, they are called as ohmic conductors, and which do not obey, they are called as non-ohmic conductors. So children, here to identify the difference between the ohmic and non-ohmic, simply the graphs are given in our textbook. That is the most important. For ohmic devices, it is the V, voltage, and what is the thing about potential difference? Clear? VI. For that, the nature of graph is straight line. What is the nature of graph? Straight line. Clear? For what? Ohmic devices. For ohmic devices, graph is what? Straight line. Clear? For non-ohmic devices, it is not a straight line, other than a straight line. What it is? Other than straight line, we will get anything whatever may be. It is a curve or any shape whatever may be. Here, for non-ohmic devices, we are showing like this. So it is not a straight line. That's why here again this is V and this is I. This is graph for what? Non-ohmic conductors. So it is a like, what is the nature of graph? Curve or other than straight line. So children, Ohm's law, for the examples, almost all will take the maximum number of metals can obey the Ohm's law. That's why almost all maximum number of metals can be taken as the ohmic devices, and for non-ohmic devices we will take the examples are the semiconductors, especially germanium or silicon. These two are should be taken as the semiconductors. For these, the graph should be not a straight line, it is like a curve shape. That's why what you have to say, they are the non-ohmic conductors. So children, what are the limitations of Ohm's law? This is also very important. There are few conditions are there. Children, already we discussed what is Ohm's law. At constant temperature, V is proportional to I. V is proportional to I. That's why what you have to say in definition only it is there. The Ohm's law is applicable at constant temperature only. That's why the first limitation is what? So first limitation is what? Ohm's law is applicable. Ohm's law is applicable at constant temperature only. At constant temperature only. For example, we are doing the experiment. While we are doing the experiment, if there is any rise in the current or if there is any surrounding temperature changes, then the rise or fall in temperature also decides the relation between the V and I. That's why when temperature changes, Ohm's law is not applicable. It should be operated at the only constant temperature. That's the first thing. And the second thing is here for gaseous conductors. For gaseous conductors, it is not applicable. For gaseous conductors, it is not applicable. And third one is here. Just now I told you for semiconductors also it is not applicable. So children, these are the limitations of the Ohm's law. So dear students, in our channel so many 10th class topics are already uploaded and still I am uploading. So if you want to get the more videos and more subject from my channel, then subscribe my channel, follow my channel and share my channel. Okay, thank you for watching.